right, welcome back. What we're going to talk about today is we're going to be talking about how to find zeros. Zeros of a function. Now, many of you probably have found zeros before, didn't even know it, or maybe you do remember, just need a little brush up, so this is what this tutorial is supposed to do. To find zeros, there's some things that I always state, is that when you're finding zeros, there are many names that you are associated with this. For example, you have found zeros, you have found X-intercepts of a graph, intercepts of a graph. You have found also the solutions of a function, or solutions of equation, solutions of an equation. All right. You have done several different things. Many times you'll say find f of x equaling 0. Okay. Other ways of saying it are aka finding the roots. The roots of the equation. In any case, what you are doing is you are finding zeros of a function, or you're finding x-intercepts of a graph, or doing all those different things. They all mean the same thing. Now, this is what many times you see in pre-calculus and higher level mathematics, where they say f of x equals 0. And what that means is that you have f of x, which is y, which equals y, and you're setting that equal to 0. And so what that means is that since the y is 0, all right, we are finding the x-intercepts, because if you recall, x-intercepts are when we're looking for an x value, but the y is 0. We're finding a root, or find the solutions, because we're actually setting a function or equation equal to 0. That's how we find the solutions of an equation. That's why we always solve equations by setting it equal to 0. Okay, so all these things you have done, except a lot of students find it difficult to actually do it at times. All right, now when you're finding zeros, basically there are different ways of going about it. The easiest way is, let's say we have a function, and here's an example, example number 1, all right, of a function where you have f(x cubed minus 24x squared minus x plus 6. Okay, here is a polynomial, all right, we know and love. Now, to find this polynomial, to find these zeros, what we can do is we first set it equal to 0, and now we solve for x. Okay, so solve for x. All right, set equal to 0. All right, first step, and then solve for x. All right, so from here, now we're going to do our algebra. Now, without your calculator, a lot of the algebra steps that we're going to perform can be just factoring. But in this case, when you have a cubic with 4 terms, we're going to do something that, or try to do something that's called grouping. What grouping is that we take the first 2 terms and we factor out something from them. So I always say one of these things just a the other. What can we factor out? We can factor out a 4x squared. When we do that, we have x minus 6 right here. And now we're looking for, in these 2 terms, a factor that is going to equal, or an expression that's x minus 6. So in order to get x minus 6, I notice I can factor out a negative 1. When I factor out a negative 1, I'll have x minus 6. Make sure you put that in parentheses. And now with grouping is, once again with grouping, okay, is that we are going to be factoring out now this expression, this common expression. When we do that, we have x minus 6, we have 4x squared minus 1 equals 0, and now we're going to set each one of these expressions equal to 0 and solve. So this one, where will x minus 6 equal 0? Well, we know that x equaling 6, all right, is one of the solutions, or one of the zeros of the function. We also can have right here, when we solve this one, 4x squared minus 1, so that equals 0. We add 1 divided by 4, that equals x squared. And now we're going to take the square root, plus or minus 1/4, which equals plus or minus 1/2. All right, and that is how we find the zeros. So what we have are these as our solutions. So our solutions, or x-intercepts, or our zeros of the function, all right, are x equaling 6 and x equaling plus or minus 1/2. Now, just to verify this, what we can do is we can also use our calculator to determine this. All right, if you take out your calculator, we can go over here and punch this equation, all right, into our calculator. So you go to y equals, and I have other things up here, but we can put in 4x cubed we have minus 24x squared minus x plus 6. All right. If we go zoom 6, we can see that, and we can find out our graph. Okay. Graph looks a little weird, but now we can find out what our zeros are. If you go to Sig and calculate, we can find our zeros by going to the right and left side. So we're going to go through, and we can kind of determine what these are. The left bound, and we go to a right bound, press enter again. It's guessing, and we realize it's going to be negative 1/2, okay, negative 0.5. We can do that to all three of them, and we'll realize that what it comes up to be is, all right, negative 6, which is right here, all right, and positive 1/2, which is right there, and we have the negative. Right. So we do it for all three. All right. Now, that's how you find zeros of a polynomial. And simply you do factor. There's many different ways of factoring. That's how we do it. Other more complicated ways to find zeros are ones like this. And example number 2. All right. If we had, for example, a function, and we're asked to find the zeros of this, so our function in this case, all right, so we're going to find zeros. So that's what we're doing. That's our goal. And we have 2 minus 7 over x. Now, in this problem, what we have, all right, we're going to set this equal to 0 again. But the key in this problem is that we are looking at it, and we're going to solve this using algebra. Well, you notice that we have a rational function. Now, when we have a rational function, the first thing that you want to do, if you can, is determine the domain, okay, and simplify it if possible, okay? What will that do? Because you don't want to have what are called extraneous roots, solutions that are undefined, but yet you get as possible zeros. You want to eliminate that. From here, and looking at this one, we can see that right here we have 2 minus 7x. Okay, we realize that in our domain, whatever solution I get, x cannot equal 0, because that is in the denominator right there. Okay, that's where it's undefined. So when we get a solution, if we get a solution of 0, that is not one of our solutions. So that is not a 0. It's undefined there. So to help us figure this one out, we're going to solve this, all right, by setting it up and solving for 0. So I'm going to subtract 2 to the other side. We have 7 over x. I'm going to multiply both sides by x now. When we get that, is these will cancel out. We're left with negative 7 equals negative 2 times x. And now I'm going to divide by 2. We have x equaling 7/2. All right, that's our solution. All right, and that's what we have. It is not 0, so that one is okay. All right, so I guess the second step is, all right, solve for x. All right, so find the domain and simplify, and then simply solve for x, just like we do with the other one. Okay, you can verify this on your graphic calculator. We go over here. Do the same thing. We'll go 2 minus 7 divided by x. We'll graph that. And we do see one right there. We'll go second calculate. We can find our 0. And we can go over on this spot, left side, press enter. For the right bound, so the right bound has to be past the 0. We're applying the intermediate value theorem for those that are aware of that. All right. Positive negative value, and we get 3.5, which is 7/2, which is 7/2. So we verified it graphically as well. All right, that's right there. All right, one last one I want to do. All right, it deals with rationals again. Is when we have something like so. All right, example number 3. We're going to have f of x equals 2x squared minus 9 over 3 minus x. Now this one is probably most commonly done wrong by a lot of students, and they forget what to do. Okay? And what I try to remember or help out students when they have rational functions. This is a rational function. A rational function. A rational function refers to that it is a ratio. All right? A ratio. If you don't know what a ratio is like is 1 to 2, or it can be written as a fraction of 1 over 2. It's a fraction. Now, what I always tell my students, I'm telling you, is that when I think of rational numbers and when I'm finding zeros of this, is I think of fractions when it is a fraction. When is a fraction 0? Well, a fraction is 0 when it's 0 in the numerator. So if I had 0 over 2, it would be 0. If I had 0 over 10, it would be 0. If I had 0 over 100, it still would equal 0. The only time it doesn't equal 0 is when you have 0 over 0. And that one does not exist or is undefined. So when we're looking for this, that is why in the key, I said in the top, is that you really want to identify the domain or simplify the expression first. Okay, identify the domain because you do not want to have, all right, 0 over 0. Because that is not a 0, that is just an undetermined form. Okay, indeterminate form. So in this one, we're going to first just find the domain, just so we have our working example. Notice in the denominator, x cannot equal 3. Okay, because the denominator cannot equal 0. Denominator cannot equal 0. We know that. So once we have that, the second step is once we find the domain, is now we can solve. Now, when you have a rational function, really the key thing is you solve for x. But for this one easy way is a lot of students will multiply both sides by 3 minus x and then eliminate with the 0. But what you can also do is just simply know that since we know that the numerator has to equal 0 in order to get 0, simply just take the numerator and set it equal to 0. All right. So that's what I'm going to do. I'm going to take my numerator, I'm set equal to 0, 2x squared minus 9 equals 0. Solve. I have 9, 2x squared, 9 divided by 2 equals x squared. And then what we have then, take the square root, plus or minus the square root of 9 halves. Okay, which is plus or minus 3 over the square root of 2, which if you're a superstar would say would be 3 squared root of 2 over 2. All right, you can verify this on your graphing calculator. Once again, just to verify, you can go and punch in 2x squared, minus 9, and divide that by the quantity 3 minus x. And then we're going to graph this. And hey, what do you know? Wow, that's a cool, neat looking graph. And we see our 2 zeros there. Okay, we can identify that if you want to here, so you can calculate. Go to 0 again. All right, we're going to have a positive, negative 1. It appears that they're in the same spot. Since I'm over here already, I'll just go to the easiest resistance. Left bound here, press enter. Right bound, on the other side, positive value, press enter again, and that is our value. Okay, so 3 over the square root of 2 is 2.121 whatnot. And it would be the opposite of that on the other side. All right, so finding zeros. In a real quick recap, finding zeros of a function are when f of x equals 0. It is when you're finding the x-intercepts on a graph, because we're looking for when the y equals 0. If x equals 0, that means y equals 0. It's also known as find the solutions of an equation or the roots of an equation. Okay. When you have a polynomial, the key thing is we always set it equal to 0 and we solve for x. Okay. When you simply have a straight polynomial or a simple regular function or power function. When you get rational functions, the key thing is find the domain in case you have extraneous solutions and then solve for x before you go. But you always do set it equal to 0 when you solve. And another one, make sure with rational functions like the previous, is that you find the domain. You really need to find the domain first. All right, find the domain, okay, and then solve for x. But be careful that you always check to make sure you're not getting those extraneous solutions. All right, hope that helps, and have good luck on your homework.